Hi folks, I hope you are all doing well and are enjoying the PhD Talks Day. In case you don't know me, my name is Adam, and for the past 3.5 years, I've been working on my PhD project under the supervision of Dr. Simon Urbanek and Dr. Paul Marel. And actually, I've handed in my thesis about a week ago, so congratulations to me, I guess, and and perhaps this can sort of motivate those of you who are in your final year. And still wanted to participate in the PG Talks Day because I think I've been fairly lucky with my project that I got to work on some interesting stuff, and I thought that this could potentially be interesting to some of you because I'll be sort of showing you some things that you can do with interactive graphics. And so anyway, my thesis had two key components. So one part was the more theoretical part, and the other was the applied part, which was actually developing an interactive data visualization library. And I originally wanted to include some of the theory as well, but then I realized that it's probably more interesting to me than anyone else, and that you probably get more out of me actually showing you how to use the package and what you can do with interactive graphics. So anyway, without further ado, I'm going to get to the live demo. So I've got an R session open up here in our studio. And the data we will be exploring today comes from the Czech Institute of Information and Statistics. And specifically, it comes from the National Health Information Portal. And the data set itself is a data about long-term psychiatric care in Czechia, and it's released as part of Open Data Initiative. And each observation in this data set records a cohort of patients who have been released from a psychiatric care facility between the years 2010 to 2022 across all of Czechia. So it is quite a quite a robust and comprehensive longitudinal data set, which makes it sort of nice for doing some exploration. So I'll read in the data and I'll show you what it looks like. So the first thing to notice here is that the data set actually comes to us pre-aggregated. So I'll direct your attention to these cases and days variables, which are which we can interpret in the context of the rest of the data, that the other variables basically specify a specific category of patients who have been released in a specific year, in a specific region, have been on particular gender, had a particular diagnosis, have been of particular age, and so on. And then the cases variable says how many patients there were, and the days variable says how many days in care they have spent in total, right? So it is not the case that every row of the data set would be an individual patient, but instead, for most rows of the data, it is a cohort of patients who have sort of had the same sort of demographic profile. And that's something that we should perhaps be mindful of during further analysis. And so to actually start exploring the data with my plotscaper package, we need to first have the package installed. And so since the package is on CRAN, you can either install it, if you're using RStudio, you can go to the packages tab, click install, and then just find the package here. Alternatively, you can also use the install packages function. So you can do install packages, plotscaper, and that should all work fine. And then you actually need to load in the package. And so let's just start with something simple. So let's start with a simple scatter plot. So to do this, we have to call a couple functions, which sort of I'll explain in a bit more depth later. But anyway, we started with this create schema function, which we just passed the name of the dataset as the first argument. And then we can start adding plots. So for example, here we just want to add one scatter plot, and we want to plot the cases against days, right? And then we need to call the render function. So Now if I run this, it's going to start rendering the plot. And this takes a little bit of time in RStudio because it's using actually like a web browser under the hood, so it can be for some dataset sizes this can take a little bit of time. But anyway, so now we have the plot, and the important thing here to mention is that this is right off the bat. This is an interactive plot, so we can do some basic things, like we can make, for example, the size of the points larger or smaller. We can perhaps make them sort of semi-transparent, things like that. And we can also, for instance, I can hold down the Q key and I can query the individual points so I can see what sort of underlying statistics they have. And there's a bunch of other interactions that some of them I'll go into and some of them are covered on the package's websites, but it's basically, all interactive features are included right off the bat. And if you actually look at the data in the plot, we see something quite interesting in that, so we're plotting the relationship of the number of cases in the given patient cohort and the number of days the patient have spent in care. And there seems to be this like roughly linear trend, but it's split between these three kind of like leaflets, where for some cohorts of patients, this relationship is quite sort of not as steep, and for some it's quite steep. So, in the absence of other information about the data set, this might be quite peculiar, but one thing you might have noticed about the data earlier, if you have a look, there's the stay category variable, which basically records whether the patients were internalized for a short, medium, or long-term stay. So it kind of hints that maybe this pattern could be explained by the different stay care categories. And so if you want to actually investigate this, we can add an additional plot. So we can add a bar plot. So add a bar plot with stay category. And now if I re-render the figure, it's going to take a little bit of time, but now we have the bar plot in there as well. And what we can do now is if we can click on the different bars, and we see the corresponding cases being highlighted in the scatter plot. So now we can actually very quickly verify that yes, these actually do correspond to the different stay care, to the different stay categories. And this is still quite interesting that we don't really see an overlap between these leaflets. So what this perhaps suggests is that patients are either being sort of kept in care for longer or are being released early in order to sort of match those categories. And that could be perhaps due to either like insurance reasons or some administrative reasons like that. Yeah, so it's just been like a quick quick way to show you what we can do with these interactive plots. And now I want to talk about one particular feature of plotscaper, which is this separation between what I call a schema and a scene. So by default, this create schema function creates a schema, which is essentially just like a recipe for creating the figure. So you can think of it a little similar to how ggplot2 figures are made, is that you have a recipe for how the whole plot should be rendered. And that's like really like an immutable data structure. So if you have a look here on the schema that I've just saved here, it is just sort of like a list of messages that tells the sort of the plotting framework what to do. And I can actually turn this into a plot by calling the render function with it. So, again, this takes a little bit of time, but the important thing is that I can also save this call to render to a variable. So if I do this, it might seem that like it doesn't really get us anything because I can still re-render the same plot. However, the important thing is that like if I save this to a variable, I now have a handle to the live figure. So I can do things like I can, for example, change the axis limits in the scatter plot. So for example, if I do this, it's going to adjust the scatter plot, and importantly, it doesn't re-render the whole figure. It just adjusts that one particular plot in the figure. Or I could, for instance, change the ordering of the bar plot breaks. So for example, so if I do it like this, I can say I want the breaks to be short, medium, and long, and it's going to reorder those bars immediately, right? And I didn't have to wait for the figure to re-render. Also, what I can do is I can select points in the same way that before I did it by clicking the bars, like so. I can also do this by calling the function. So I could say select cases, and I can say, let's say, select the first 1000 cases of the data, and it's going to show up in the figure as well, right? And as a final thing, I can also add or remove entire plots. So I can first call this plot function, which is going to drop the bar plot, and then I can add it back in, right? And so this is, I think, quite powerful in that if you want, you can have your immutable schema like ggplot, and you can always re-render the whole figure from scratch. But if you want to do something with the figure as it's sort of sitting in RStudio, you can also do that. So I think this is quite handy, and that's essentially what I have here. And the one other thing that I wanted to show is that essentially the hypothesis that I had there about the sort of the state categories being sort of separate is we can also check that by looking at the average number of days that the patients stay in care. And if we do that, we actually see indeed that, for example, the short-term stay patients, 95% of them stay, in this case, well, like 90% of them stay between 4 and 67 days in care, and the medium stay between 93 and 161 days. So there's quite a gap between the 67 and 93. So that's basically the gaps that we see here between those sleeves. And yeah, so that's one thing that we can quickly find out about the data. It's quite interesting. And so for the next sort of section, I'm going to create a bit more sort of complicated figure. So this one is going to contain a lot of bar plots because many of the variables in the data are categorical. So again, I'll sort of create this figure. I'll save it after it's been rendered, so then I can sort of do some other things with it. And I'll also set the layout of the figure. So what I'm going to do here is I'm going to make this this sort of bottom left plot a bit wider. So that just sort of to make it easier to see some sort of patterns and trends in the data, and that you can see there, so, what you can do with the package. And so here now I have bunch of these different plots where these two in the top row they show the sum of cases and the sum of days across the years. So this basically show like how many patients are in care or have been released from care, and how many days they have spent in care. So overall we see that generally this is quite uniform, or that perhaps fewer patients are being sort of released from care, but the number of days that they spend in care is pretty constant. So that sort of tracks with what we know about the healthcare system, is that we usually have a limited number of placements for people to be in the care. So that's the number of days that the patient spend there, doesn't really fluctuate too much over time. Then we have this plot showing the different age categories and also the sum of cases of the patients who are in those age categories. Then there is a just like a simple bar plot with the two different gender categories, and then there is a bar plot with diagnoses, right? And so I just wanted to create this figure because it's, I think, quite like interesting for exploring how the different what sort of demographic factors the different diagnoses are correlated with. So we can again, by pressing the Q key, we can quickly query the individual diagnoses, and we can see that, for example, the diagnosis with the highest number of cases of all time has been alcohol-related disorders. And if I click on this bar, I can immediately see that these alcohol-related disorders, they seem to be sort of most prevalent in people around the ages 49 to 60. And importantly, we can also see this even if we normalize the plot, which means that we make the height of the bars constant. We see that this isn't just because of the fact that they are sort of most people are aged between, let's say, 30 to 60, but it's also it's also true proportionally. So we can do the switching between the different bar plot representations by pressing the N key. And we also see that this is more prevalent in males. So again, if I normalize this plot, we see that it's about twice as prevalent, these alcohol use disorders in males than females. And so if you have a look at the other, the sort of second most prevalent disorder, that's schizophrenia. And here we see some differences. So for example, now the male to female ratios are a bit more even. We see that there are still a bit more males with schizophrenia probably. But if you have a look at it proportionally, we see that the proportion in the population is about the same. So there are more male patients in general, but the proportion of male and females with schizophrenia is about the same. And similarly, in the age category, we see that the schizophrenia patients are perhaps a bit younger than were those with the alcohol-related disorders. And if you normalize it, we see that it is, this disorder seems to be a bit more uniformly distributed across ages. So it seems to sort of start around, let's say, 20 to 29, and then it's, has about the same distribution throughout the age. And the other two important things I want to highlight is that schizophrenia seems to have, over time, the number of cases with schizophrenia seems to have declined. So if I normalize this, there seems to be this small but fairly steady downward trend. But if you have a look at the number of days, this actually seems to be increasing. So this is quite interesting in that it means that we have fewer patients hospitalized with schizophrenia, but they are staying in the facilities for longer. So this could mean that the healthcare system is being it's being burdened by the patients who require sort of longer care, and that might be a like potential warning sign, right? And so let's look at some of the other disorders. So the third most prevalent is Alzheimer's disease. Here we again see like a very strong age trend. So now this is the most sort of common disease in these sort of the 70 or the 70, 79 and 80 plus category. It is a bit more prevalent in females, which again that kind of makes sense since we know that women on average tend to live longer. So that there would be correlation between the age and the sex. And then there are, again, we see this interesting pattern here that the proportion of patients who make Alzheimer's have stayed relatively constant. but perhaps the proportion of days that they might make up of the people staying in care has slightly increased. So, so that's also quite interesting. And then of these other sort of these top five disorder categories, there are neurotic disorders, which are again more prevalent in women, and are sort of more distributed towards the sort of the younger side of the age spectrum. And then the final of the top five are substance use related disorders excluding alcohol, and those seem to be very common in particularly young people. So here we see that the most sort of represented category is 20 to 29, or let's have a look at it proportionally. Yeah, it is the 20 to 29 are the most common. And so those are some interesting trends in the top five. And I've spent some time sort of looking at this data set, and I have a sort of chapter in my thesis about what I've been sort of able to discover with the package. And you can do that for quite a while. The one I think like interesting trend with some of these sort of less common disorders is that there's this like fairly here I'll mark it here. This fairly rare category of disorders are physiological disorders, and those you can't really see on the other plots without zooming in. So let's do that. Let's zoom in here, and first of all, if we zoom in gender, we see that these physiological disorders are way more common in females than they are in males. And if we zoom in on the age, we see that these tend to be common in the sort of the youngest age categories, so in like the ages 0 to 19. And now let's zoom in on the year and the number of cases, and we see that both the number of cases and the number of days those patients stay in care has increased over time. So that's quite unusual, because for most other disorders, the number of cases has actually been sort of decreasing, because what I was saying before, like with the schizophrenia, that one has sort of had the number of days increasing. So it's perhaps most of the patients, the patients with the sort of perhaps less serious disorders aren't perhaps even able to receive care generally. But that's not true for for these patients with the physiological disorders, which are based on the data primarily young girls. So so this is quite concerning, because also these physiological disorders include, among others, eating disorders, and those have been on the rise sort of across the developed world in the last maybe 10 to 20 years, quite a lot. So so this is potentially like a worrying trend in that whereas for most other disorders the numbers of cases are going down, for physiological disorders they are going up. So that's just something that I wanted to show you, that you can sort of do with interactive graphics, and that you can very quickly gain understanding of your data set by having these couple different sort of interactive tools that you can do. And there's a whole bunch of information on the package's website and in my thesis if you want to have a look. Yeah, so anyway, that's my presentation. So as I was saying, my thesis is on GitHub Pages, and it's got interactive graphs in a couple of the chapters, and then there's also there's a sort of applied example chapter which you might use to get some ideas. Then the data itself comes from the Czech Institute of Health, from their website. So if you want to have a look, it is here's part of the Open Data Initiative. Then I also have 2 videos on my YouTube channel on how, like, if you want to use my package, how to do it. And the last but not least, if you were actually interested in the theory behind some of the things in the package, then we have this paper here that we published last year, which was in the Journal of Computational and Graphical Statistics. So anyway, that's everything for me. I hope you've found this interesting or potentially useful, and I hope you have a great rest of the PhD Talks day. And yeah, thank you very much for your attention.